Welcome back everyone. In this lesson we're going to begin to create our player character, and this player is going to do a few things. First of all, it's going to be a third person character, meaning that we're going to be able to see the player. We'll be able to then rotate the camera around and move around and jump around as well. So to begin, let's go ahead, create a new scene here, and this is going to be of type kinematic body. Now, a kinematic body node is basically a physics node, which is really useful for if you want moving characters that can collide with environments, can walk over things, can detect when they're standing on the ground, and a bunch of other things that you might want for a physics character body. I'm going to rename this here to our player. I'm going to then save the scene as player.tscn. And now for our player, we need to add in a few things. First of all, we need to be able to see our player, so let's add in a primitive mesh, which is going to just be a capsule model. Although if you do have a model for the player that you want to use, you can of course do that. I'm just going to go add child node. I'm going to then go mesh instance right here. And this mesh instance, we can go over to the inspector. And in here, what we want to do is set the mesh to be a new capsule mesh right here. We'll select that so it opens up the properties. Let's set the radius to 0.5, and we'll set the mid height here to, we'll keep that at 1. But as you can see, it's pretty much sideways, so let's go down to, I'll close this up, let's go down to transform. I'm going to set the translation here to be 1 on the Y, and on the rotation degrees, I'm going to set 90 on the X, so it is facing upwards like that. There we go. Okay, so we got the player capsule. Now let's just rename this to model. I'm then going to add in a collision shape, as that's what the kinematic body requires, because right now we don't have a collider, so we'll just fall right through the floor. So add child node, collision shape right here, create that, set the shape to be the exact same as the model, so we'll set it as a capsule shape, we'll set the radius to be 0.5, we'll set the transform translation on the Y to be 1, and the rotation degrees on the X to be 90, so it matches up with our capsule right here. Okay, so we got the main player objects set up right here. Now what we need to do is create our camera. Now for our camera, Godot has a easy camera node we can just create, and that will render the scene for us automatically. So let's go player, we'll right click on that, add child node, and we want to add in a camera right here. So there we go, we've got our camera, but what we want to do is have the ability to have this camera over here, for example, like just behind the player a bit, and then have it actually rotate around, sort of orbit around the player. Now we could do this in script by calculating the center position of the player relative to our position and then do some maths to figure that out, but that's a bit overcomplicated for what we really need. And to make this a lot easier, what we can do is make this camera a child of a empty node, which is going to be in the middle of the player, and instead of rotating the camera, we'll rotate that node around just on its axes. That won't move around at all, so that will make it much easier to move around the camera. So I'm going to create a new node as a child of player here. This one is just going to be a spatial node. And with this spatial node, what we want to do is rename it to camera orbit. Let's set it to the middle position of the player. So it's at the feet right now, but let's move it up a bit. So maybe we'll set the translation on the Y to be 1. So it is sort of going to be orbiting around the center of the player right there. Okay, and now what we want to do is just drag in the camera as a child. For our camera, let's set it to a position. So in transform, we'll set the translation on the X to be -1, Y is going to be 1, and Z is going to be -5. There we go. The reason why it's over here and not over here is because we want the player to be facing, by default, in the forward direction. And that is along the blue axis right here, positive on the Z. So if the camera's back here, we're looking towards positive Z, and that is the forward direction, which we're going to be then using later on in order to move the player around. Okay, and let's rotate the camera because the camera's facing the wrong way, so we'll set on the rotation degrees on the Y to 180. There we go, the camera's now flipped. And if you want to have a preview of what this looks like, we can just go up here to preview, click that box, and there we go. This is what we're going to be seeing by default. This is what our camera sees pretty much. So pretty much from here, that's the camera setup. The script that we're going to be creating later on won't be attached to the camera, but it will be attached to the camera orbit. So we'll be able to then modify the rotation degrees on the Y here, for example. And you can't really see it here there on the Y, but on the X, for example, you'll see that we can rotate it up and down, and this camera then orbits around the player pretty easily. We don't have to worry about modifying the position of the camera. We just need to rotate the camera orbit object. Alright, so I'm just going to untick preview here so we get out of that. And now what we need to do is set up our weapon, because the player's going to be holding a sword. So in order to do that, let's go ahead and I'm going to create an empty object first of all, because we need a weapon holder that's going to hold the sword model, and the weapon holder is going to be what also is animated rather than animating the actual model, as since the model will probably have to scale it down a bit. So working with like translations and rotations when you have ununiform scales isn't really the best thing to do. So let's go create a new child node on player, create a new spatial here. I'm going to call this one our weapon holder, and I'm going to move this over to the player's right arm. You can of course choose left or right arm. So in transform, I'm going to set the translation to be negative 0.58 on the X, 1 on the Y, and just to make it go out of the player's body a bit, we're going to make it 0.035 on the Z here, so it goes forward just a tiny bit. Okay, so there we go. We got the sword holder, or the weapon holder. Now what we can do is go to our models folder, and then you'll see that we have a sword.dae right here. Now DAE, this is pretty much very similar to the .fbx model format if you ever used that before, but the benefit with DAE is that it's open source, so it works with Godot by default. So we can just drag this in like so, and as you can see, our sword is very large. Make sure it is a child of the weapon holder here, and what we need to do first of all is set the position here to be 0, 0, 0. And of course it is very large, so what we need to do is scale it down. So I'm going to set the scale to be 0.15, 0.15, 0.15. There we go, that's about the right size. And we just need to rotate it now, so I'm going to set the rotation degrees on the Y to be 90. And let's have it at a bit of an angle, so 45 on the Z, so it looks like that. We can click on our camera again and check out the preview to see how it looks. There we go, we got our player with the sword. We can unpreview now. Alright, so we got all of our objects here pretty much set up and ready to go. We got our sword, we got our camera, we got our player model. Finally, what we need to do is add in the attack Raycast, which is going to be basically how we detect if we're looking at an enemy when we attack them. So I'm going to add in a new node here, and this is going to be a Raycast node. Now, if you don't know what a Raycast is, think of it as a sort of way to see what is in front of us or what is in a certain direction. Because with a Raycast, you give it a position, then you give it a direction to go towards, and what it does is it pretty much shoots a little point from one position in a certain direction, and pretty much if it hits something, it'll return information on that. So think of it sort of as a gun, for example. In fact, many games use Raycasts for their guns. When you shoot a gun, it goes, and the bullet goes along from the muzzle in the direction it is facing, and if it hits something, it gets detected pretty much. We can then get information back of what we hit, and in our case, we're going to be checking to see if we hit an enemy. So we got our Raycast here. I'm just going to rename this to Attack Raycast, and I'm going to set the transform translation here, the position, to be negative 0.3, 1.6 right here. So it is sort of in the middle of the player, but a little bit over towards the sword, because we don't want to be able to hit an enemy that's not really in line with the sword. And you can see this white line right here, and this white line pretty much shows how far our Raycast is going to go. So pretty much anything that intersects this white line right here will be detected by the Raycast. So I'm going to click enabled up here, otherwise it won't be working. And we want to change the cast to, so it is going to be facing in our forward direction here, not down. So we'll keep X on 0, we'll set Y to 0, and we'll set Z to be 1.5. There we go, we now have the line pointing out this direction from our player. So pretty much whenever there's an enemy inside of this line right here and we attack them, that damage will be dealt to them. Alright, so that is pretty much it. We've got everything here set up and ready to go. Now if we go back to the main scene, what we can do is in fact go ahead and drag in our enemy. So go to the file system, drag an instance of the player. I'm going to set their position to be 0, 0, 0, so they're right in the middle of the level. And there we go. We can see that the players in the level, they look about to scale. We might actually need to move them up a bit because it seems like they're clipping into the ground. We'll move them up to 0.3 high, so they're sitting on the surface. And yeah, now all we can do is press play and see how it looks. And there we go. We've got our player in the scene, but of course we don't have the ability to move the camera around or move the player around. We'll be working on that in the next lesson. Welcome back everyone. In this lesson we're going to begin to actually set up our camera look, have the ability for our camera to orbit around our player when we move the mouse around. So we got our player scene right here inside of our main scene. So what I'm going to do is go over to the player scene, select our camera orbit object, which is the empty spatial node which has the camera as a child of it. We're going to go to our camera orbit and we're going to create a new script. This one is going to be called camera orbit right here, camera orbit.gd. Alright, so here we are inside of the script. I'm just going to remove these default templates right here. So first of all, we're going to begin with our variables, okay? First up, we have the look sensitivity, so variable look sensitivity, and this is going to be a float, and by default will equal 15. Now, look sensitivity is just going to be basically how fast is the camera going to rotate based on how fast our mouse moves. Alright, then we need a min look angle. This is going to be a float, and we'll have this equal negative 20.0 by default. Now, the min look angle is pretty much how far down can the camera rotate, because we don't want to be able to rotate the camera all 360 degrees around the player, because otherwise that will cause issues with how the camera orbits around. It'll just be very disorientating for the player. So we're going to sort of clamp the vertical rotation of the camera. And along with min, we also need a max look angle of type float, and this will equal 75. So how far up can the camera rotate? Alright, that's the three main variables done. Now what we need to do is keep track of the mouse delta. And the mouse delta is pretty much each frame, how fast, and in what direction did the mouse move. So we'll go var mouse delta, and this is going to be of type vector2 for an x and y in screen coordinates. And we'll just have this by default equal an empty vector2. Now we just need to get the player object. And the reason why is because when we rotate the camera around, we're going to be rotating the camera orbit object up and down, so we can look above the player, we can look towards more horizontally along the player. But when we rotate sideways, whenever we want the player to rotate around its y-axis, we're not going to actually be rotating the camera. Instead, we're going to be rotating the player. And the reason why is because later on, once we get into moving the player around, instead of having to figure out which direction the player is facing and then get that based off its current direction, all we're going to do is just get whatever direction the player is looking forward in and move based on that. That's just going to make it a lot simpler for us. So I'm also going to go down here and go var player, and this is going to be an onReady variable. So once the game has started and this node is initialized, we are going to get underscore parent, which will just get the parent node of this one. So the parent node of camera orbit is the player kinematic body node. That's our variables there. Now let's set up a function that gets us this mouse delta, because how are we going to actually figure out how fast and in what direction our mouse has moved each frame? Well, we can do that inside of the underscore input function. So func underscore input, you should see that it automatically pops up with something here we can hit enter on. And this is a function that is built into Godot. And this event here just contains all the information of whatever's been pressed down, whatever's been happening based on your keyboard, your mouse, or any other controllers you have that frame. So what we're going to do here is we are going to set mouse delta whenever we move our mouse. So to check if we've moved our mouse, we can go if event is input event mouse motion. So if we have moved the mouse around this frame, then we can just go mouse delta equals event dot relative, and there we go. It's as easy as that, just 2 lines of code. So each frame when we move our mouse around, this vector here will be filled in, and then inside of the process function, which we can go ahead and create now, func underscore process, it creates automatically with a delta parameter. This function gets called every single frame, so if the game is running at 60 FPS, this will be called 60 times a second. And delta here, this parameter, is basically the duration between each frame. And we use this in order to do stuff based on per second rather than per frame, which just makes it frame rate independent. Nothing's tied to the frame rate then. So what we want to do here is get the rotation pretty much. What rotation are we going to be applying to the camera and the player? So we'll go var rot equals, and this is going to be a new vector3 because we're going to be rotating around the x and the y value, but not the z, because z is sort of tilting it sideways, but we still need to include it here. We'll just have it as 0. So for the x, this is going to be mouse delta.y, because if we're rotating along the x-axis, that is going to rotate the camera up and down, so that's going to be mouse movement up and down. And then horizontally, that's going to be x, so mouse delta.x, and 0 for the z. Now we just need to multiply this by the look sensitivity and multiply it by delta as well. And multiplying it by delta just gives us a bit of a smoother camera rotation. Okay, so we got that rotation variable there set up. Now we need to apply this rotation to the camera and to the player. So first up, we're going to apply the vertical rotation. This is the rotation when we move the mouse up and down. It's going to be rotating the camera orbit object to look above the player and below the player. So what we're going to do is just go rotation underscore degrees dot x plus equals rot.x. Oops, don't need any of that at the end there. Rot.x. Now we can do that, but if we keep moving our mouse up, it's going to eventually do a loop around the player, but we don't want that. We want to clamp this position. We want to clamp the rotation around the player. So to do that, we can go rotation underscore degrees dot x equals, and then we can do something known as the clamp function. And the clamp function is really handy because we can give it 3 values. We give it a value that we want to clamp, which is going to be the rotation underscore degrees dot x, and then we give it a minimum and a maximum value. And pretty much it's going to make sure that this value that we've given it stays in between the minimum and the maximum given values. So min is going to be our min look angle, and max is going to be our max look angle as well. So we're rotating the camera vertically now. What we need to do then is rotate the player horizontally, because when we rotate the camera sideways, we're not going to be rotating the camera orbit object, we're going to be rotating the entire player. So for that, we can just go player.rotation underscore degrees dot y, and then this is just going to be minus equals rot.y. Alright, now the reason why we're not going to be clamping this value is because if we're rotating sideways, there's no real limit that we can go. We can go 360 degrees around as much as we want, really, because there is no sort of limit that we're going to reach. And finally, we just need to clear the mouse delta, so mouse delta equals vector2, and this just is so that if we stop moving our mouse, we don't keep rotating around in the same direction. Okay, so we got all this set up. We're getting the mouse delta, we're getting the relative input, which is basically how fast and in what direction the mouse has moved each frame. Then we are getting the rotation, so we're getting the x and the y, multiplying that by our look speed and then by delta. And then down here we're rotating the we're rotating the camera here up and down, and then we're rotating the player sideways. And then we're clearing the mouse delta. So let's go ahead, we'll press play and see if this works. Alright, we've got our player here, let's move our mouse around. If I move left to right, you'll see that our player is moving around, and if I move up and down, you see that just the camera is moving. And that's what we want. You can of course tweak this to however you want. If you want the camera to move independently of the player as well, so if you want the horizontal camera to only rotate the camera and not the player, you can of course do that, but we're just going to have it like this for now. You might also notice something, and that is that the mouse is still here. So if we go off screen, you'll see that the mouse no longer rotates the player, so when we're moving around, it might be a bit annoying to work with that. So what we can do is basically lock the mouse cursor. So at the start of the game, this mouse is hidden and it is locked to the screen, which is really what you want for these games that control the camera with the mouse. So we're going to do that inside of the underscore ready function, which gets called once when the node is initialized, so right at the start of the game. And what we want to do here is hide the mouse cursor. So I'm going to go input.set underscore mouse underscore mode. And the mode we want to set to this mouse, you'll see that there's 4 different ones right here. Visible is what we have right now, and the mouse is visible, we can see it. Hidden is when the mouse is hidden on screen, but it can still move around. Confined is when it is pretty much confined to the screen, but we can still see it. And captured is when it's confined to the screen, but it is also hidden, and that's what we want. So we want mouse mode captured here. Let's press play, and you should see now that the mouse is no longer appearing on the screen. So we can move around as much as we want, and the mouse isn't going to fall off the screen. Alright, great. But one thing you may notice is that you can't click on the X now to get out of this. Escape doesn't work, nothing works. So to get out of this, we can just go Alt and F4, which will quit the window right here, and it will return us back to the editor. Now, in the next lesson, we're going to go on and actually start scripting our player, setting up the player movement and some of their other functions so we can start platforming our player, jumping around, and later on start attacking enemies. So thanks for watching, and I'll see you in the next lesson. Welcome back everyone. In this lesson, we're going to begin to script our player, have the ability to move around with the WASD keys, jump with the spacebar, and yeah, from there we'll then move on to attacking and collecting coins. So to begin, what we need to do is set up our actions, because whenever our player wants to move, we need to know which keys on the keyboard do what things. What do we need to press in order to move forward, back, left, right, jump? So let's go over to the project button up here, then go project settings. And in here, we want to go to the input map tab, and we're going to create some actions. An action can be a key press, a mouse button click, or anything with a joystick, controller, stuff like that. So we're going to make a few actions here. We're going to have move underscore forward, press enter to create a new action, move underscore backward, move underscore left, move underscore right, and then we're going to have jump and attack. Okay, so we got our 6 new actions over here, and what we're going to do is click on the plus icon for move forward here. We'll go key, because this is going to be a keyboard key, and then we can just enter in the key that we want. So I'm just going to press W, there we go, hit OK, and move forward is now assigned to W. We can do move backward here to S, move left can be A, move right can be D, jump can be space, and for attack this is going to be a mouse button, so we're going to go mouse button, and then mouse button index is going to be left mouse here, and we'll just set the device to all devices just to make sure, because by default it's set to device 0, although that may not work if there's some problem with how it's connected, so we'll just set all devices. And there we go. Alright, we can close out of that. Now in our player scene, let's go ahead, select our player node right here. I'm going to create a new script, which is going to be called player.gd. We can remove this base template stuff here, and what we're going to do is begin with our variables. So first up, we need to know our current HP. That's going to be of type int, and we'll have that equal to 10 by default. Then our max HP, which is going to be the max amount of HP we can get, and we'll have that 10 as well. Then we want to know how much damage we do, so whenever we attack an enemy, how much damage are we going to be dealing to them? We have an int, and we'll have that as 1 by default. Later on, we're going to implement gold, so we can collect coins, so we'll have gold int equals 0. And then we also need to know, for attacking, how often can we attack? What's the minimum amount of time between clicks are we allowed to attack? That's going to be our attack rate of type float, and we'll have this equal 0.3. So every 0.3 seconds we can attack again, and this is going to be tied to the length of our animation. We also need to know the last attack time, and the last attack time here is just going to be in terms of milliseconds from when we last attacked, and we're going to be getting that from looking at our computer's current time. We'll be doing all that later on, but we'll just have the variable here for now, int equals 0. And after this, we need to get on with some of the physics stuff. So first of all, our move speed, which is going to be a float. We'll have this equal 5.0. So we're going to be moving 5.0 meters per second. Then we have jump force. So how much force is going to be applied upwards when we press the spacebar to jump. This will be a float, and will equal 10. And after this, we also need to know gravity, because we are going to have gravity being applied to us. This is going to be of type float, and we'll have this at 15.0. So we got that, we got our gravity. Now let's also create a variable, which is going to be a vector3. We'll call it vel for velocity, of type vector3 equals a new vector3. And velocity is just going to be our basic velocity. Where are we moving, which direction, and at what sort of speed. So we need to keep track of that. And finally, some of our components, we need to know the camera and the attack raycast. So for the camera, this will be an onReady var, because we are going to be getting this when the node is initialized. Camera equals get underscore node, and we want to get the camera orbit object, which holds our camera script. Okay, so we got the camera, and then we need to get the attack cast. So let's go to var attack raycast here equals get underscore node, and we need to get the attack raycast right here. That's all our variables set up and ready to go. Now what we can do is start on actually moving the player around inside of the physics process function. Now the physics process function is a function which gets called 60 times a second. It's different to the normal process function, which gets called every frame. And this is just in order to maintain consistency with physics. So if you're working with anything with physics, such as what we're doing right here, it's good to do that in the physics process function. So we can here go func underscore physics underscore process. It's built into Godot, and delta here is the time between each frame. So what we want to do here first of all is set our x and z velocity to 0, because when we're not clicking a button, we don't want to keep moving. We want to pretty much stop moving straight away. So vel.x equals 0 and vel.z equals 0 as well. And then after this, we want to be able to get our input vector, and the input vector is going to be filled in whenever we press on a button, a WASD. So this is going to be pretty much a vector that gets the inputs, and then we'll be applying that to our velocity, applying it and modifying it a bit later on. So var input equals vector3, and now we need to check each of our key presses. So if an action is pressed, the move forwards, backwards, left, right action, we need to modify this input vector right here. So we can go if input.is underscore action underscore pressed, and the action here is going to be move forward. Then what we're going to do is go input.z plus equals 1. So we're moving forward, so we need to increase z here by 1, so z would then be, so the input vector would then be 0, 0, 1. If we want to move backwards, so we'll do the same thing here, if input.is underscore action pressed, and that would be the move backward, then we just want to go input.z minus equals 1. Now I'm just going to copy and paste this right here, paste it down like so. Also remember to put the colon at the end of a statement. We'll replace these ones with x, and move backwards with move underscore left, and move underscore right. So there we go. We're getting all of the axes right here to be assigned to the input vector right now. And what we can do now is normalize this vector. Now what normalizing the vector does is makes it so that we don't move faster horizontally. Because if you think about it, the magnitude of this vector here, which is pretty much all the three axes added together, so x, y, and z added together, if we're moving forward, our input vector here is going to be 0, 0, 1, so the magnitude is going to be 1. If we're moving horizontally, the z is going to be 1, and the x is going to be 1. So the magnitude of that is going to be 2. So we're going to move twice the speed if we move diagonally. So we want to prevent that, so if we're moving diagonally, then our forward and right speed will be halved. So to do that, we can just go input equals input.normalized, like so. Okay, so we're normalizing the value. Now what we need to do is figure out which direction we are facing. And the reason why is because when we press left, right, whenever we want to move in a certain direction, we don't want to move based on the global direction. So if we're looking straight and we press forward, we'll move forward, but if we then rotate 90 degrees and we press forward, we'll start moving left. So we don't want that. We want to move based on the direction we're looking. So for that, we need to figure out which direction we're looking in. So I'll go var dir, and this will be equal to, and in brackets here, I'm going to go transform.basis.z, which is our forward direction, our local forward direction, multiplied by input.z plus transform.basis.x, which is our right direction, multiplied by input.x. And there we go. That is our direction right here. It is a vector 3 as well. So what we need to do now with this is set our velocity on the x and z axes. So here we can just go vel.x equals dir.x multiplied by move speed, and then vel.z equals dir.z multiplied by move speed. There we go. So now what we're doing is we are assigning our velocity to be the correct direction and the correct speed. Now next up, we need to work on implementing gravity, and that is going to be worked on in the next lesson. So in the next lesson, we'll implement gravity, we'll implement jumping, and this will then allow us to create a basic platformer character for our game. So we can move around, we can jump, we can look around, all that good stuff. So I'll see you all then in the next lesson. Welcome back everyone. In the previous lesson, we began to create our player script right here. We set up our variables, then we went ahead and started implementing the player movement. So we got the key inputs right here. We're then normalizing the inputs so we don't move faster diagonally. Then we're calculating our local direction in which we're going to be moving in. And then we are basically setting up our velocity right here so it has the appropriate move speed. Now in this lesson, to finish off the movement, we're going to be implementing gravity and jumping, and then finally actually moving the player along that velocity. So first up, let's start with gravity. So for gravity, all we need to do is modify the y velocity, so the vertical velocity of the player. So here I'm just going to go vel.y minus equals gravity, and then we need to multiply that by the delta, which is basically the duration between 2 frames. Since the physics process function here does get called 60 times a second. And this here is basically going to increase the gravity over time. So if we fall from a high height, we're going to speed up as we move downwards. Alright, so we've got our gravity. Now I'm just going to leave a comment here. And next up, we are going to implement the ability to jump, because we have the jump inputs. So let's now detect for when we press the jump button. So we can go if input dot is underscore action pressed, and the action we're going to be checking for is jump. Then what we're going to do is we are going to just set our y velocity to be the jump force. So vel.y equals jump force. And then we can also implement a little comment here that just says jump input. Okay, so we got this here. So whenever we press the space button, we're going to be jumping. But one problem is that as long as we have the spacebar held down, we're going to continuously be setting our y velocity here. And that's not what we want. We want to make it so that only when we're standing on the ground can we jump. So in order to do that, we could do some complex maths with Raycast and all that, but since we are using a kinematic body node right here, what this allows us to do is just have one function call to see if we're on the floor. So we can go if input is action press jump and is underscore on underscore floor, which is a function in the kinematic body node. This basically just tells us yes or no for whether or not we are standing on the floor. So if we're standing on the floor and we press the jump button, then we're going to set our y velocity. Okay, we got that. Now, and finally, what we can do is modify our velocity over time, move the player. So in order to do that, I'm just going to leave a comment here, move along the current velocity. We're going to be using a function that also comes with the kinematic body, and this allows us to move the body along a certain velocity and also detect collisions and also detect which way the floor is facing. So that can also tie in with checking to see then if we're standing on the floor, and overall this is probably the best way to do player movement if you want to have a physics-based character that can jump, that can land on platforms, that can detect when they're on the ground. So for this, we're just going to go vel equals, and the reason why we're doing equals is because this function returns a velocity, which is always good to put back into the velocity right here. So vel equals move underscore and underscore slide, and then what we're going to be giving it is our velocity, so we'll just go vel, and then optionally we can give it some other things, and we want to give it the up direction. And the up direction is basically which way is the ground facing. So since our ground is on our feet, the ground is going to be facing upwards. So we can just give it a vector for that. I'm just going to go vector3.up, which is a pre-built vector in Godot here, which is just 0 on the x, 1 on the y, and 0 on the z. And that's pretty much it. So what we can do now is press play, and we should be able to look around with our camera, just like before. But now when we use the WASD keys, we can move left, we can move right, back, and forwards. We can jump with space, and as you can see, if we spam space, we don't jump until we land on the ground. Let's go try some platforming. There we go. And wherever we are looking is the direction that our forward direction is in, as you can see, which is really good. So overall from here, this is the player controller set up and complete. You can of course add in many more features, tweak it to be a bit better. Maybe we want some smoothing of when the player starts moving, stuff like that. But overall, if you just want a player controller that you can easily chuck in a game and 100% work, then this is a good way to go. So just go Alt F4 to quit out the game. And yeah, so let's just go over real quick of what we've been doing right here. On our player script, we set up our variables here. Now, not all of them are being used right now. Many of them, such as gold and attack rate, stuff like that, is what we're going to be using later on once we implement those functions. But we got the main physics process function here, which gets called 60 times a second, which is really good if you want to do some physics-based coding. We are initially setting our X and Z velocity to 0 so that we don't just press the left button and we keep moving left even when we're not pressing it. Then we're creating an input vector, which is what is used to detect the inputs from the keyboard. So when we press the move forwards button, we're setting Z to be +1. When we move backwards, -1. Left, right, we're setting the X value. Now with the input, we're normalizing it because if we hold, let's just say W and D, we're going to move forwards and right at a faster speed, since the magnitude of that velocity is going to be 2 rather than just 1 if we're moving in just a single direction. So we're making it here that when we move diagonally, we're going to be moving at the same speed as if we're just moving in one direction. Then down here, we're getting the relative direction, so we're basically getting the forward direction, multiplying that by the forward input. Then we're getting the right direction and multiplying that by the right input to get us our local relative direction to wherever we're facing in the world. Over here then, we are setting our X and our Z velocity to be our direction property over here, multiplied by the move speed, so we can have a varied move speed. Then we're setting our gravity, so over time we are basically decreasing our Y velocity over time so that we fall. And multiplying it by delta here just makes it so that the gravity isn't instantly super fast. We're moving in gravity here, basically per second squared. So if we go up here, look at our gravity, it's 15. Now in real life, gravity is around 9.5, I believe. And the reason why it is so high is because in video games, a low gravity that is close to Earth doesn't really feel that natural. It doesn't actually feel that real, because in video games you're normally jumping at much greater heights as you would in real life and falling from much greater heights. So if you were to have a real life sort of gravity, then it would actually feel really slow. Many games have a gravity of around 15 or even high, up to 20, just because it feels much more natural for video games. Okay, then down here in the jump input, we're detecting for when we press the spacebar or the jump action right here. Then we're checking to see if we're standing on the floor. If so, we're setting the Y velocity to be jump force, so we're instantly shooting up into the air. And then if we're no longer pressing space, gravity is going to be taking over from there. And finally, with all that stuff set up and going, we're going to be setting our velocity to the move and slide function, which is going to move us along that velocity, keeping in mind that the up direction is where the floor is, so it can detect stuff such as if we're standing on the floor, and if we are going to be hitting anything so that we don't go through colliders, we bump into them and stop moving. And that overall is the movement here set up and done. In the next lesson, we're going to be starting to begin implementing gold coins, so we have something to collect, and we're then going to be creating functions here on the player, which can also then tick up whenever we collect the gold coin. And then later on, when we create a UI system, our current gold amount will be displayed on screen. So thanks for watching, and I'll see you all in the next lesson.